Good morning, friends and dear students. It gives me immense pleasure to be here again for my course Aircraft Systems. I am here again for the module number 4, and this is my second lecture of the module number 4. The module number 4, the title is Engine Control and the Fuel Systems. Today is lecture number 27. I am Dr. Y.D. Dwivedhi, Professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this process, I am in module number 4, and before that, I will go for my topic of the day is principle of operation of aircraft gas turbine engine, and I will be discussing about gas turbine engine, their principles, their basic theory. These all things I am going to discuss. And as you know that I have a huge amount of working experience in gas turbine engines. I was maintenance engineer for Arthur's turbo mecha engine used in Alwat or Chetak helicopter. It is a turbo shaft engine which consists of 3 stages of axial flow compressor and 1 stage of centrifugal flow compressor. Then we have the combustion chamber. Then we have turbine, a very simple gas turbine engine which is used by the turbo mecha Arthur's engine. Nowadays, this company has become the Chevron. Olden days, it was turbo mecha. So now, few companies have joined hand and they are now France origin, Chevron. This Chevron also interested to make the gas turbine engine for the light combat aircraft LCA Tejas, our indigenous Indian fighter aircraft, which is one of the best light aircraft in the world. In this aircraft is in phase of development, and we are going to shortly, in few years, we are going to make AMCA. This will be one of the 5th generation aircraft which will be used for Indian Defence Forces. In today's class, I am going to take revision. Then I will go for the basic cycles which is used for the aircraft aero engine, principles of operation of aircraft gas turbine engines, parts of a jet engine and its functions. This I am going to discuss one by one. And in my previous class, in lecture number 26, I have discussed about flight control, that FADEC, the full authority digital engine control system, FADEC. I have given a brief idea about that. In this, I will be totally discussing about gas turbine engine, how it is functioning, how the cycles are used, their principle of operations, and different parts used in aircraft like inlet, then compressor, combustion chamber, turbine, nozzles, all things I am going to discuss in this lecture. So if I talk about the revision, you know that in my module 1, I will talk about first the module 1, and in module 1, I have discussed about airframe system, vehicle system, C is avionics system. Mission system. This is the module 1 I have covered. If I talk about the module 2, in module 2 I have covered the electrical system. In this AC system, DC system, AC system variable frequency, and constant frequency, power generation, I am writing PG, power generation, and in DC we have 28 volt DC and 270 volt DC. This we have, and we have also seen different control systems, different safety devices. These are all things we have discussed in electrical system. Then in module 2 only we have seen the oxygen system. We have seen the environmental control system. In this, air conditioning. And then we have seen the pressure control system. Then we have seen here in that anti-icing and de-icing system, fire extinguishing system, and so on. This is my module 2. Now if I talk about the module 3, we have seen that first is hydraulic system, then I will write as A, and B is a pneumatic system. So these things we have covered already, and you will see that now I am in module number 4, and this module number 4 is basically engine and fuel control. This is my module 4, which I am going to discuss in my today's class. So you might have seen that in my previous class I have discussed about interfacing between the system and the environment. So your system and your environment should be interfaced by some interface unit. In aircraft, engine and the pilot, there should be some mechanism. That mechanism is called interface unit. Here I have shown here. This is the interface unit. This interface unit is making here aircraft interface in cockpit. So how pilot is able to see the cockpit very nicely. This you can see here. So it is able to see this thing very nicely, and it should give a very correct reading, correct values, so that pilot should not get any confusion. As you can see here, this is the head-up display, HUD. So in olden days, if you see this one, there are so many switches here, so many. Pilot has to be very much stressed. Always he has to observe this all the switches, all the meters and all the precautions. But now this is the modern digital cockpit, which nowadays all Airbus, Boeing, all these aircrafts are using this. And why we use this modern digital cockpit? It gives lot of safety, lot of comfort, lot of efficient flying of the pilot. That makes the a free hand, or the pilot need not to put its more effort on flying activities. He or she has to see only the safety aspects of the aircraft. Otherwise, all the parameters, all the type of flight, even landing and takeoff is performed automatically by the help of autopilot and by the help of the FADEC systems. So you can see, if the pilot has to see below the cockpit, then he cannot see the front runway. During landing, he has to see the front also. So nowadays, the head-up display is there. All the parameters of the instrument, which is below the range of its eyes, they are visible in this small glass. This you can see, this one. So this makes here pilot can see all the parameters. Oh, he need not to see here below. That is the advantage of the head-up display. In fighter aircraft nowadays, we have got helmet mounted display in place of this HUD. HMDs are there. Okay, these helmet mounted displays are used to, pilot can see in the helmet glass all the things, all the instrument of the cockpit as per its requirement. He or she can see all the things on the helmet. So after turning the helmet, the head left, right, up and down, every time all the instruments of cockpits are visible on its helmet glass. Same way here, just like head-up display is, small glass is here. In this glass, all the parameters of these instruments are visible. It gives very clear vision of the pilot, and pilot need not to see the bottom of this cockpit. She has to see the runway also. So runway and the front side, for any bird hit or any abnormalities in the runway, pilots can observe. That is why it is very good, and this can be happen only with the help of interfacing between the software, between the hardware, and between the human. All has to be mixed together and they should get the result. So that is the purpose of the interfacing. Now how this interfacing works. This works by the help of the flight management system. Flight management system is nothing but it is a computer operated system. In this computer operated system, flight management system, the air data is here. This air data is received by the flight management system. From here it gets, from the pitot tube or from other equipments, the information is achieved by this flight management system. From here, if you see, we have the surveillance system. The flight management system will get input from the surveillance system. It will also get from the navigational receiver. So here receiver and the transmitter, if NDB, VOR or any other navigation aids, they will give sense to this and it will communicate to this flight management system. Engine and fuel, here we have the FADEC, full authority digital engine control system. It will sense the speed, torque, power of the engine, and as per this directive of the flight management system, this will work and it will give the power as directed by the flight management system. Then we have the aircraft displays. I have shown you just now. This you can see here. All the displays are here. These displays are performed by the flight management system. Here we have some data link. This data link also from all the equipment inside they are fitted, they will give their feedback, their operational ability, and any fault, anything, any redundancy parameters has to be communicated to the flight management system. Next, we have the inertial reference system. In this inertial reference system, the inertial navigation like acceleration, velocity, distance travel, these all things will be measured by the help of the gyroscope and accelerometer, and this is transmitted to the flight management system, and this flight management system will activate necessary engine control system or the flight control system so that the necessary location can be achieved. Here we have the flight controls. These flight controls are working nowadays by the fly-by-wire, and next is fly-by-optics. It is started now, fly-by-optics. These are already existing, and all flight controls, we know that there are three primary flight control systems: elevator, aileron, and the rudder. Elevators make the aircraft, if aircraft is flying like this, nose up and nose down is done by the help of the elevator, which is on the horizontal tail. If you want to make the rolling, then you have to use the ailerons. Ailerons are there on the wing tips. One will go up, another will go down. Aircraft will go roll accordingly. And if you want to make yaw, yaw is done by the help of the rudder. Rudder is on the vertical tail. I will just show here. It will be nice if I am showing a diagram here. This is the tail, this is the wing, and this is the rudder. So here, this is the rudder here. If you see, this is the elevator, and here we have the aileron. This is the x-axis, this is the y-axis, and this is the z-axis. Z, x, and y. So if you want to roll, this rolling is done on the longitudinal or x-axis. Pitching is done on the y-axis. Pitching is done by elevator. Rolling is done by the aileron, and yawing is done by rudder. And this is on the z-axis. Means nose going left or the right. It is called the y-axis. And these are the three primary flight control system which are there in every aircraft. Okay, so this I have just explained about this interfacing and how these things are happening. And now I will go for the today's class, and this I have already explained before. This up to here, it is just revision of my previous classes. Now I will go for my topic, which is gas turbine engine. And these type of aircrafts are used, these types of engines are used now. All types of modern aircrafts, let it be passenger or military. Okay, so these things are done. Now I will first go with the first diagram. Just I will draw here first, then I will write second, then I will write here third. I will go one by one. Here I give the basic cycle. And what is the cycle? Cycle is a continuous process in which the work and this process goes one by one and the work is obtained. So we give something input. Input we may get from as a fuel, and we will get some torque on the shaft. So how it is happening? Just first I will explain with this diagram. Here we have fresh air is sucked. This suction is achieved. It is one number here. This is achieved by this compressor. Compressor is rotated. And how this is rotated? Initially it is rotated by the help of the battery or by help of the APU, auxiliary power unit, which is started before the main engine is started. If it is on the ground, we use the ground batteries or the ground trolley that will supply power to this compressor, and your whole system will operate. As and when it is started, starting time will take nearly 50 to 60 seconds. In this 50 to 60 seconds, the air will be sucked inside, compressor will suck it. There will be number of compressions, number of stages of the compressor. It may be 2 stages, 4 stages, 5 stages, 17 stages, up to 20 stages I have seen compressors as per the type of engine. And in every stage, if you see, air is entering from here, and every stage pressure ratio is nearly 1.2 pressure ratio in every stage is increased. As it is going here, this you can see, diameter of this is more than the diameter of this. It means this much air is compressed, and now the air volume is only this much. So if you see this diagram, it is the pressure is quietly increased. If the pressure is increased, the volume of your air is also decreased. So if it is the 1 atmosphere here, at the exit of this compressor you may get 20 atmosphere. It is depend upon the number of stages. If it is a small engine, you may have the 5 stages. Medium, you have the 10 stages. If it is a big power, then you have the 20 stages. So these are 5, 10, 20. I have given in numbers. This is depend upon the how much the load your aircraft is able to carry. Now the compressor has reached to some pressure, and this goes to the combustion chamber. In combustion chamber, we will use the injector. Injector will inject fuel. It is injected, and same time here there is a spark plug. It will give the spark, and your fuel, mostly we use the ATFK in turbine engine, ATFK 50, Jet A1. This is the name of the fuel which normally we use. ATFK is what? It is aircraft turbine fuel kerosene minus 50. Minus 50 indicate that it can work up to minus 50 degrees centigrade of temperature. This fuel is suitable up to minus 50 degrees centigrade of temperature. If the temperature of the atmosphere is below minus 50, then this fuel is not much suitable. That time we have to use some additives. For your information, I can say that I got this opportunity to travel to Antarctica as a scientist team, and we have operated our 2 helicopters in our Gangotri and Yamunotri to our bases on the Antarctica, and I was there for some 3 to 4 months during summer from March to June. So there we used to mix some additives. They are methanol or some low freezing point additives, some 1%, 2%, as per the temperature, as per the it is going to the minus temperature, that much more percentage of. So if it is going up to from minus 50 to minus 75 or minus 80, we use 1%. If it is minus 80 to 100, we will use 2%. From 100 to 150, we will use 3%. Like this, we will increase the percentage of additive. This is also makes one disadvantage, that the power producing capacity of the engine is reduced, because the methanol or the carbon tetrachloride which we add in this fuel is not giving the same amount of calorie as the ATFK 50. So that much few percentage, maybe if we are adding 1%, the power production capacity of engine may reduce to 2 to 3%. If we are adding to 3%, power production capacity of the engine will reduce to 10%. So normally we will not encourage to do this mixing of additives on our fuel. But sometimes we require to do these all things. That time we have to take the chance and we have to complete our mission for which we are designed. Okay, so now we can see here that so this our air is entered here. We have injected by the injection wheel or by injector, and here we will give the spark. Fuel will burn here. This burned fuel with a high temperature and high pressure will enter to the turbine. Here if you see the shape of the turbine, here area is less and here area is more. What does it indicate? It is opposite to the compressor. So what it means? Here we have the volume is less as it is going to the different stages. I will just draw here. Turbine is okay. So here if you see, we have number of stages like this, like this, like this, like this. Okay. So in every stage the volume will start increasing like this. Okay. So it is increasing. Your volume is increasing, and so expansion is taking place. In turbine, what happened? Expansion is taking place. This expansion of volume will give the work done. This work done is given to the shaft. This shaft will rotate. This will also be rotating this, and your external power supply or APU, which we have initially connected to start this engine, is disconnected now, and this engine is now taking over all the things, and this exhaust gases will come out of the system. This whole system is also explained in figure number 2 here and the figure number 3. Figure number 2 shows the pressure and the volume changes, and figure number 3 shows temperature and entropy diagram. So here this you can see that 1 and 2 here compression, here this 1 and 2, it is a constant entropy. 1 and 2, it is a compression is taking place like this. This is happening due to the rotation of the compressor. Air is sucked. So initially this you can see here, initially the volume is here, it is a V1. Now this after the compression, volume has become V2. So here V1 is greater than V2. So this you can see here. Here the volume is more. At the 1 you have the volume more, and if you see here, volume is less. So this volume is shown by this. So pressure is increasing, volume is decreasing. As you reach to 2 and 3, it is a constant pressure ignition. Here Q in. Here Q means it is a heat. Heat in. So here how heat in? It is a combustion chamber. In this combustion chamber, fuel is injected and it is ignited. This will happen at a constant pressure 2 to 3. In this, pressure is constant, but volume has increased from 2 to 3. So it was initially 2, now it is more than 1. It is now V3. So up to here, this is the V3. Here volume is increased due to this combustion. Now, if you see that further in turbine also, this volume is increasing from V3 at constant entropy. Expansion 3 to 4 is taking place in the turbine. This you can see here it is 3 and this is the 4. Here expansion, gas is expanding like this, and by this expansion volume is increasing and heat is converted to the work, and this work is given as a torque to this shaft, and this shaft is rotating the compressor, and also it gives the velocity, and this exhaust gases with a high velocity will go to the nozzle. Here is the nozzle. This nozzle will give the thrust to the jet aircraft, and this aircraft will move forward. If it is a propeller aircraft, this jet is no use. Only the torque which is produced by the shaft is connected actually in this side. So this will be connected with the propeller. This is the propeller. Okay. This is the propeller. So in this way we can get the power of the system. So here Q out, heat energy is going out. The balance of energy is going out. So here Q in minus Q out divided by Q in. This is the efficiency of thermal efficiency of the engine. Okay, so in this way we can find out what is the same thing. If you see here, temperature and the entropy variation, here 1 and 2 and here this 1 2, it is a constant entropy. It means 1 2 is a perpendicular to this. There is no change in, it is an adiabatic process. 1 2, there is no change in entropy. From 2 to 3, it is a constant pressure, heat aided. So here the pressure is constant but heat is aided in this. 3 to 4, which is a turbine expansion in the turbine. It is also a adiabatic process. 3 to 4, here also no change in entropy. S3 is equal to S4. Here S2 is equal to S1. So here we have 1 2, one constant entropy process, another is 3 4 in the turbine and the compression. Both are working on the adiabatic process. Heat addition is isobaric or constant pressure, and exhaust is also constant pressure process. So in this way I have explained this basic cycle of gas turbine engine. Hope you people have understood very well. I always request, if anyone has any query, you are welcome to ask in this mail. Always welcome to ask in this mail. Dwivedhi@gmail.com. Okay, so in this you can send me any queries. Now I will go for the vehicle system. I think you know this, I have discussed already. So I want to talk about, there are two types of the propulsion system. And what is the propulsion? Act of propelling. It means it is you are going to give some traction, some force to that your aircraft or your any vehicle should move. So here we can divide to propel, to move forward. So propulsion means act of propelling. To propel, to move forward. So if your any object is here and if you want to move from here to here, you need some force to do, and that is force which is obtained is called the propeller, propelling. Here we have the reciprocating engine. In this we have the piston engine, we have the cylinder engine. This piston and cylinder engines are moving up and down and we are getting the propulsion in this. Then we have the turbo engine. Just now I have described. We will have the one compressor, one combustor. Then we have the turbine. Then we have either we have the one shaft in this propeller will be there, or if it is not required, we will have one nozzle here. This nozzle will produce thrust by action and reaction. Okay, so these are the two basic type of propulsion system which are used in the aircraft. One is the reciprocating or the piston engine, another is the rotary engine or the gas turbine engine, and they are having some advantages and disadvantages. In due course of time, I will be going to explain about this. Now I will talk about the propulsion system of turbo engine. Here we have the gas generator, the first one. Here we give a jet engine. Second one is turboprop, prop engine, sorry, turbo prop engine. This is the turbo fan engine. This is the turbojet engine. This is the turbo fan engine. Okay, so here one simulation is there or one animation is there. But before that, I will go to the first one, turbojet. Here, if you see inlet, here air is entering. 1, 2, 3, 4, 5, 6, 7 is a LP compressor. LP compressor 1, 2, 3, 4, 5. This is the 5 stages of HP compressor. HPC, LPC. Then we have here combustion chamber. Then this is the HPT, high pressure turbine, and then 2 stages of low pressure turbine. And here is the nozzle. Okay, so this is the turbo jet engine. This is the turboprop engine, the same way, except here no nozzle. This whole engine is giving torque to this shaft. This shaft will rotate this propeller. Here we will have one gearbox. This gearbox will reduce the speed because the speed of engine is some 30,000 to 50,000 RPM. This RPM is reduced to the some 2,000 to 3,000 RPM. Our propeller will rotate in this range only, not more than that. So that much reduction we have to give by the help of gearbox. Next, and this is a very nowadays advanced engine, and most of these aircrafts nowadays, even military aircrafts like Rafale and all, they use the turbofan engine because it is more efficient, very light. These things are advantage of this thing. So here we will have one fan. From this fan, this you can see here, air is coming from here. Some air is entering in that fan. Some air is entering in the main core for going for the compressor. Here also the green one is the low pressure, yellow one is the high pressure. This reddish color here is your combustion chamber. From here it goes to the HP. This yellow color is HP turbine, and this green is again LP turbine. So from here different, here is the bypass zone 9. One is the this is the cowlings of the engine or pylons of the engine, and it is going from here to here. And this you can see the red color. Only a very small amount of air is taking part in the combustion. If you see the blue here and the red, a very small amount of red is visible. So that makes it very efficient. Very efficient engine, because additional thrust is given by this, additional thrust is given by this, and in this area total thrust is achieved. So that is the benefit of turbofan engine. Now, principles of gas turbine engine. The basic operation of the gas turbine is a Brayton cycle, which I have shown you, with air as the working fluid. Atmospheric air flows through the compressor that brings it to higher pressure. Energy is then added by spraying fuel into the air and igniting it so that the combustion generates a high temperature flow. This high temperature pressurized gas enters a turbine, producing a shaft work output in the process, used to drive the compressor. The unused energy comes out in the exhaust gases that can be repurposed for external work, such as directly producing thrust in a turbojet or rotating a second independent turbine known as a power turbine that can be connected to a fan, propeller or electric generator. The purpose of the gas turbine determines the design so that the most desirable split of energy between the thrust and the shaft work is achieved. The fourth step of the Brayton cycle is cooling of the working fluid is omitted, as a gas turbines are open that do not reuse the same air. Principle of operation of aircraft gas turbine engines. How jet engine works. Just now I have explained, just it is in the words form. So jet engines move the airplane forward with a great force that is produced by the tremendous thrust and causes the plane to fly very fast. All jet engines, which are also called gas turbines, work on the same principle. The engine sucks air in the front with a fan. A compressor raises the pressure of the air. The compressor is made with many blades attached to the shaft. The blades spin at a high speed and compress or squeeze the air. The compressed air is then sprayed with fuel and electric spark light in the mixture. So same thing, just I will show you here. Oh, this you can see here. Okay, what I am telling. This is the compressor. So it is entering here. It is compressed. From here it goes to the combustion chamber. Here we give the spark only for once. Spark we will give, and we will give the fuel injection. From here a high temperature and high pressure air will enter into the turbine, and in the turbine the air will be expanded like this, and this expansion gives the work because the volume is changing, and this volume change in the volume will give the work done. So that is the principle of this thing. The burning gases expands and blast out through the nozzle at the back of the engine. As the jet of the gas shoot backward, the engine and the aircraft are thrust forward. As the hot air is going to the nozzle, it passes through another group of blades called the turbine. The turbine is attached to the same shaft as the compressor. Spinning the turbine causes the compressor to spin. So just I will explain again. This is a shaft. In this shaft, this is the compressor. After the compression, it will go to the then you have the these are the turbine. This is the combustion chamber. This is the compressor. This is the inlet. From here air will go inside. Okay, so initially what will happen? By the help of some external source, maybe battery or some other source, APU, we start rotating this shaft. As this is rotating, it will suck the air. Air will be compressing inside this. A high pressure air will enter in this combustion chamber. From here we will be injecting fuel, and from here we will give the spark. Only for starting this spark is given. This spark, it will burn. The high temperature and the high pressure will hit these blades, and these blades will start rotating due to expansion, and this will start rotating the compressor also. If it is a turbojet engine, a nozzle will be there. The high temperature and the high pressure gases of this will enter from here and it will give thrust. If it is a propeller air engine, so more number of turbine will be there, maybe some 10 stages, and very less amount of, maybe 5 to 10% only will go for the exhaust. Remaining will be absorbed by the shaft, and this will rotate the propeller. So that is the difference. You can see by this diagram, if any aircraft having more number of stages of turbine, that engine is turboprop engine. If you have only few stages, 2, 3, 4, 5 stages of the turbine, this is a jet engine. This you can put it always. And the compression also. In the turboprop engine, you have the more number of compressors stages and more number of turbine. So the turboprop engine is heavier than the turbojet engine. So that is the disadvantage of the turboprop engine. It generates the lot of additional weight. Propeller itself is very heavy. So your turbine, your shaft, your compressor, everything will become high. Length of the aircraft engine or the turboprop engine will be high. So by the size of the length, by the diameter, by this all things, if you don't see the propeller also, by the seeing the turbine and the compressor, you can find out that whether it is a turboprop engine, it is a turboshaft engine, it is a turbojet engine, it is a turbofan engine. The very specifically, all this type of engine will have a different types of configuration. If you talk about the turboshaft engine will always have one centrifugal or two stages of the centrifugal compressor. But your turboprop and turbojet, turbofan, they will not have the centrifugal compressor. They will have mostly axial flow compressor. So by this configuration, you can identify that which one is what. Now the image shows how the air flow through the engine. The air goes through the core of the engine as well as around the core. This causes some of the air to be very hot and some to be cooler. The cooler air then mixes with the hot air at the engine. So this you can see here, the blue is your cool air, and this few goes to this bypass, few goes from this compressor, and this is the combustion chamber. From here it is burning and it is going to the respective places. So now principles of producing thrust. How the thrust is produced. What is the basic theory behind that? Everywhere we know the Newton's third law. Every action there is an equal and opposite reaction. That is the main source of inspiration and main source of concept from where we get this thrust. So thrust is a forward force that pushes the engine and therefore the airplane forward. As per Newton's third law, every action there is an equal and opposite reaction. An engine uses this principle. The engine takes in a large volume of air. The air is heated and compressed and slowed down. The air is forced through many spinning blades. By mixing this air with jet fuel, the temperature of the air can be as high as 3000 degrees centigrade. The power of the air used to turn the turbine. Finally, when the air leaves, it pushes backward out of the engine. This causes plane to move forward. So this is the basic principle of the thrust. In this way, the thrust is produced. Now I will talk about the parts of the jet engine. So the main parts of the jet engines are fan, compressor, combustor, turbine, mixer and the nozzle. All these 6 parts I have shown here. First is your fan. So ahead of the compressor, some bigger size fans are fitted. Then you have the compressor. Then you have the combustor. Combustor is also called the combustion chamber. Then you have the turbine. After the turbine, you have the mixture, and then you have the nozzle. So these all the 6 parts I am going to discuss one by one in detail in the next slides. So it is fan. So the fan is the first component in a turbofan engine. The large spinning fan sucks in large quantity of air. Most blades of the fan are made of titanium. So blades are made of titanium. This you have to remember. It then speeds their air up and split into 2 parts. One part continues through the core or the center of the engine, where it is acted upon by the other engine component. So in this, one part of the air goes to the engine inside, another part goes bypassing the engine. So it is called the bypass. The second part, that is called bypass, the core of the engine, it goes through a duct that surrounds the core to the back of the engine, where it produces much of the force that propels the airplane forward. This cooler air helps to quiet the engine as well as aiding thrust to the engine. So this bypass is having 2 benefits. The sound is reduced. The noise of this aircraft engine is turbofan is reduced, and also it is not taking part in burning, so the efficiency of the engine is also increased and thrust is also increased. So that is the benefit of the fan. So this I can show you here. This you can see here. This is the fan, and here this much is bypassing, this much and this much. Only this is the core where these things are moving. Okay, so this we have to very well, this we have to see that, and this is the advantage of. So this I have seen. Now I will talk about the compressor. The compressor is the first component in the engine core. The compressor is made up of fans with many blades and attached to a shaft. This you can see 1, 2, 3, 4. So there are number of, it may be 10 stages, 12 stages, 15, 20 stages also. Okay, so the compressor is the first component in the core of the engine. Your fan is not core, it is ahead of the core. The compressor is made up of fans with many blades and attached to a shaft. The compressor squeezes the air that enters into the progressively smaller area, resulting in an increase in the air pressure. This results in an increase in the energy potential of the air. The squeezed air is forced into the combustion chamber. Now, combustor. In the combustor, the air is mixed with fuel and then ignited. In the combustor, the air is mixed with fuel and then ignited. There are as many as 20 nozzles to spray fuel in the air stream. There are as many as 20 nozzles to spray fuel into the air stream. So there are a number of nozzles like this. They are spraying 20 nozzles, 50 nozzles in the surrounding. Okay, here, and they are spraying the fuel. The mixture of air and fuel catches fire. This provides a high temperature, high energy airflow. So as this fuel is ignited here, a high temperature, high T and high pressure is experienced inside. The fuel burns with oxygen in the compressor air, acting hot expanding gases. The inside of the combustor is often made of a ceramic materials to provide a heat resistance chamber. The heat can reach up to 2700 degrees centigrade. So it is a heat, ceramic materials are used inside the combustion chamber, and titaniums are used in the compressor and in turbofans. Now turbine, I am explaining the turbine. The after combustion chamber we have the another component is the turbine, and this you can see volume is increasing like this. If you see the compressor, it is decreasing like this. This is a compressor, and turbine it is decreasing. It is increasing. The volume of this thing is increasing. So that is the difference between a symbolic representation of compressor and symbolic representation of turbine. If you make in a line, so if this is the compressor and this is the turbine, this is the T and this is the C. This, if you are making opposite side, means you don't understand the concept of this turbine and the compressor. So make sure that you should draw properly, then only people will understand that you are aware about the basic concept of compressor and the turbine. So the turbine, the high energy airflow coming out of the combustor goes into the turbine, causing the turbine blades to rotate. The turbines are linked by a shaft to turn the blades in the compressor and to spin the intake fan at the front. This rotation takes some energy from the high energy flow that is used to drive the fan and the compressor. The gases produced in the combustion chamber moves through the turbine and spin its blade. The turbines of the jet spin around thousands of times. I told you that it may be 30,000 to 50,000 RPM. Okay, so this is the range which I have worked. 33,500 for the Artust engine. It is 33,000. It is turbofan 33,500 plus or minus 500 RPM. This is for Artust engine. Now it is called Safran, France company. Okay, so they are fixed on shaft which have several sets of ball bearing in between. So this is the shaft, and here you have the ball bearing here, you have the ball bearing here. Number of ball bearings are here so that this shaft is supported, because it is 10 meters or 12 meters of length. So that much everywhere the shaft will be supported, every meter shaft will be supported by both the side by the ball bearings. Next very important part is mixer and the nozzle. This mixer and the nozzle, this is fitted after the turbine. This mixer is mixing the cool air coming from the bypass of the fan and the hot air from the core of the engine. Both has to be mixed properly, and then this will give a high medium temperature, and the pressure will enter in the nozzle, and then nozzle it will be further expanded and the thrust will be produced. So this is the principle of the mixer and the nozzle. I am just going through this wording of this mixer and the nozzle. The nozzle is the exhaust duct of the engine. This is the engine part which actually produces the thrust for the plane. So here if you see, this is the nozzle, and these nozzles are producing the thrust. The energy depleted airflow that passed the turbine, in addition to the colder air that bypassed the engine core, produces a force when exiting the nozzle that acts to propel the engine and therefore the airplane forward. The combination of the hot air and the cold air are expelled and produced an exhaust which causes a forward thrust. The nozzle may be preceded by a mixture which combines the high temperature air coming from the engine core with the lower temperature air that was bypassed in the fan. The mixture helps to make the engine quieter. Okay, so just I am drawing here itself. This is the shaft, this is the fan, then we have the compressor, then we have the combustion chamber, then we have the turbines. So what happened? Here goes here. This is the cold air from the turbofan, and the hot air. All are mixed here in this zone, and then it is going to the nozzle, and there it is, so that the efficiency of this thing is increased, the temperature is reduced, so the material damage, chances of the material damage is also reduced. So that is why this gives a lot of benefit to the aero engine. Turbofan makes lot of better. The sound is also reduced. Okay, so these are the mixer and the nozzle, and the nozzle may be preceded by a mixture which combines the high temperature air coming from the engine core with the lower temperature air that was bypassed in the fan. The mixture helps to make the engine quieter. So if you are mixing by this mixture, the noise of the engine is tremendously reduced. So in my next class, I will be discussing about types of jet engines: turbojet, turboprop, turboshaft, ramjet, pulsejet, and so on. So please be tuned. And these are the references which are taken from Moyer and the Seabridge aircraft systems, mechanical, electrical and avionics system. The next book is from again Moyer and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. Thank you very much. If you have any questions, you are welcome to ask me. ydwivedI@gmail.com. This is my email, in which you can mail me if any query on helicopter, any query on the turbojet engine, turboprop engine, turboshaft engine, any other issues on flight mechanics, any other issues on aircraft stability and control, airport management, and so on. If any type of problem you have, the aerodynamics, aircraft propulsion, or anywhere you have any query or any question, you are welcome to drop me the mail. I will try to answer your question. Thank you very much for the joining, and please be tuned. Please subscribe this channel and also like this channel, so that I feel very good that somebody is liking. And if any query, you can give in the comment also. I will try to reply. Thank you very much for the joining this class.
Like, share and subscribe. Hit the bell icon for more updates.